The story of black holes, gateways to the unknown. Imagine a place where gravity becomes so intense that nothing, not even light, the fastest entity in the universe, can escape. This is the essence of a black hole, a mysterious region of spacetime born from the most extreme conditions in the cosmos. These enigmatic entities, predicted by Albert Einstein's groundbreaking theory of general relativity, have captivated scientists and storytellers alike for over a century. A glimpse into the abyss. The concept of a black hole begins with Einstein's 1915 theory of general relativity, which revolutionized our understanding of gravity. It showed that massive objects warp spacetime, much like a bowling ball on a trampoline. But it wasn't until 1916 that physicist Carl Schwarzschild solved Einstein's equations to describe a special case, an incredibly dense and compact mass so extreme it would create a boundary, beyond which nothing could escape. This boundary, now known as the event horizon, marks the point of no return. Yet for decades, these black holes, as they would later be called, remained a theoretical curiosity. Even their name was coined much later, in 1967, by physicist John Wheeler. Before that, they were often referred to as frozen stars or gravitationally collapsed objects. From theory to reality, the seeds of the black hole concept were sown long before Einstein. In the 18th century, philosophers John Michell and Pierre-Simon Laplace speculated about dark stars, so dense their gravity could trap light. However, without the modern understanding of spacetime, these ideas faded into obscurity. It wasn't until the 20th century that the reality of black holes began to emerge. In 1958, David Finkelstein provided the first modern interpretation: black holes as regions from which no information could escape. Theoretical work in the 1960s finally cemented black holes as a generic prediction of general relativity. But where were these celestial monsters? Did they truly exist? In 1967, Jocelyn Bell Burnell's discovery of neutron stars, dense remnants of stellar collapse, hinted that black holes might be out there too. Just a few years later, astronomers identified the first strong candidate, Cygnus X1, a binary system emitting powerful X-rays, suggesting the presence of a black hole, devouring matter from its stellar companion. The universe's invisible architects. Black holes come in many sizes, from the stellar mass black holes that form when massive stars exhaust their nuclear fuel and collapse, to the supermassive black holes, millions to billions of times the Sun's mass. These cosmic behemoths reside at the hearts of galaxies, shaping their evolution and anchoring their structure. Our own Milky Way galaxy hosts a supermassive black hole, Sagittarius A star. Its existence was confirmed by observing the orbits of nearby stars, which revealed an invisible object with a mass 4.3 million times that of the Sun. Though we cannot see it, Sagittarius A star governs the dance of countless stars in our galaxy's core. How black holes grow. A black hole is not a static entity. It is a voracious devourer. Once formed, it grows by consuming gas, dust, stars, and even other black holes. Material falling into a black hole doesn't vanish silently. It forms an accretion disk, a swirling maelstrom of gas heated to millions of degrees by friction. These disks emit intense radiation, sometimes powering quasars, the brightest objects in the universe. Occasionally, a star wanders too close to a supermassive black hole. Its immense gravity stretches the star into a glowing streamer of gas in a process called spaghettification before the remnants spiral into the void. These events, though destructive, light up the surrounding cosmos with spectacular brilliance. A black hole's secrets. Despite their darkness, black holes are not entirely silent. In 1974, Stephen Hawking showed that quantum effects allow black holes to emit faint radiation, now called Hawking radiation. This emission gives black holes a temperature inversely proportional to their mass. For stellar black holes, this temperature is just billionths of a Kelvin, rendering it impossible to observe directly with current technology. Yet, black holes continue to reveal their presence through their gravitational influence. By observing the motion of stars and gas, astronomers can calculate a black hole's mass and infer its location. These indirect methods have identified numerous black hole candidates across the universe, deepening our understanding of these enigmatic objects. Masters of the cosmos, black holes are no longer merely the stuff of theoretical musings. They are essential players in the story of our universe. From the quiet, stellar mass remnants scattered throughout galaxies to the supermassive titans orchestrating cosmic evolution, black holes are both destroyers and creators. They remain among the greatest mysteries of modern physics, offering tantalizing glimpses into the nature of spacetime, matter, and even quantum mechanics. As scientists continue to study these cosmic enigmas, each new discovery challenges our understanding of the universe and our place within it. Black holes remind us that the cosmos is a realm of wonder, where reality often exceeds imagination.